On va commencer par se présenter.
Hi, my name is Remy Andreoli. I'm working in an innovative company called Bluesham, and we are specialized in using geospatial data for decision-making purpose.
Hello, I'm Thomas. I'm working for a company specialized in data named Apid for alternative projects for intelligence in data. We have also a component in open source tools and wish to develop the free philosophies, free software philosophy.
Hi, I'm Sabine Ferrat. I'm a pedagogical teacher, in fact, in James Cook International School.
Hello, I'm Benoit. I'm a teacher of science at James Cook.
And I'm from the same school, so my name is Iman. I'm the SACE coordinator, so I coordinate the degree that we offer for the high school at James Cook. So.
Thank you.
Very good. Yeah, we will.
So I don't know if you know what the James Cook school is. Maybe you can explain to them what
Yes.
James Cook school is.
Yeah, in fact, we are an international school and we develop different diplomas, and especially a SACE, International Diploma, a SACE, Australian Certificate of Education.
So it ranges from the primary to the secondary school, and we have a primary school, and then we have the high schoolers up until the year 12.
Oh, great.
Good, good. Yes.
We were supposed to have the someone from the University of New Caledonia, NASA, who is specialized in data at the university. She used to work with ecosystem dealing with geospatial data, and she's a PhD professor. And I don't know why she's not here, or maybe she couldn't come. We were supposed to get another startup, Janai Toko Toko. I don't know where is he.
I sent a message to them.
And we are supposed to be connected with a student from Lifu, the island of Lifu, from the island province. Where are they?
They are downloading
The
Zoom.
Technical issue.
So I don't know.
That's far away.
Yeah.
Let's try to call them.
Yeah, I called them already. They still.
Okay.
And it's good that we are actually recording, because like, yeah, if they won't be able to make it, we will just share the video afterwards too.
Yes. Image. Okay. 90% of download.
Yeah, it's a big file.
Okay.
C'est-à-dire quoi, 19,
80%. 70% déjà for.
We wait a little bit.
Il y avait
Hein?
Insight aussi qui.
Oui.
Insight avait prévu de venir.
On attend un peu ou vous voulez qu'on commence? Comment?
On peut attendre.
Attendre un peu? Oui. Or maybe you can introduce yourself and tell a story,
Yeah,
Yeah.
about how you shape this space challenge for the benefit of our ecosystem.
So I think we're gonna share some slides.
We have some of our personal story in there.
Yeah, so
in the slides.
yeah, let me see.
So
Are you able to see the slides?
Perfect. Yeah.
Perfect. Okay. Great. So again, bonjour, and I guess it's bon après-midi now. And we are just as by intro, we are going to talk about a few things. We'll talk about ourselves and like who we are and how we got basically inspired to be part of working in the space industry. And then we'll talk about climate change, which is the motivation for why we started the challenge. And the challenge has been going on for 4 years or for different years now, and for this particular one, we're focused on methane. And so Eric will talk a little bit more about the problem area that we're trying to address. And then I will end with just the mechanics of how you can actually participate in the competition. So I think that's sort of like the agenda that we have prepared today. And then afterwards, ask any question, and also feel free to interrupt us if you have a question during the actual presentation, since we're a small group and we can certainly just do this more as like a discussion.
And the first part is just our personal story, so that we can wait and see if our friend can join.
Yeah.
It won't miss anything.
Okay, so let me just like start. So I'm Emmeline Pat Dahlstrom. I am actually Filipino and also American, because I lived most of my life in the Philippines, and then I immigrated to the US after also living in Europe and in Canada. My background is physics and space science, but I really mostly worked on program development, operations, educational management, mostly on the tertiary and postgraduate level. Worked with the International Space University and Singularity University, which is like focused on basically graduate level space education. And also exponential technologies. And then I also worked for space startup companies in the US, ranging from basically space tourism. So 20 years ago, we sent space tourists to the International Space Station, all the way to working with startup companies that are working on building like landers and rovers like to the moon. Eric.
Yeah, I'm Eric. I'm from the US. I started studying physics and astronomy and mapping the galaxy with radio astronomy. And then I went into space engineering and worked for many years for NASA on space station design and some other projects, working for big companies like Lockheed and Raytheon. And then I was involved for many years with the International Space University, which is how Emmeline and I met.
So we were both students.
And so the International Space University moves around the world and is hosted by different cities. And it's going to be it just started in Brazil. And so I'll be
for
going
this year,
and I'll be going over there next month. So in California, we were helping lots of space startups get created, and but we've always been interested in international space activities.
Which is why, even though we are actually based in New Zealand today, we still maintain our global space community network, and we're still working with projects that are actually based in the US. So really, our story is that like 6 years ago, we actually moved to New Zealand because there was a program called the Edmund Hillary Fellowship Program, which was for entrepreneurs and investors to come to New Zealand and work on a scalable project, an impactful project. And so our project basically was incorporating and creating SpaceBase. And so SpaceBase is really, I think about it as a purpose-driven consulting, because we're a social enterprise that's really focused on the democratization of access to space. And when we say that, the reason that we are kind of like focused on this is that we are, actually, I think your other, let me just admit the people that are online. All right, I think they're now
which is good. They just missed the art introduction. That's
which
That's
is yeah, which is good. So yeah, as I was mentioning, the SpaceBase, we created SpaceBase, and the reason was that it's on the premise that, you know, space or space industry, the global space industry, will be, you know, pivotal and important to kind of like the future of humanity. And if we really believe that, we want to make sure that nobody gets left behind, and so that all of the opportunities are actually given to everybody around the world. And so that's sort of like why our main focus is creating space ecosystems and growing space industries, particularly in developing and emerging countries. And so we thought that coming to New Zealand, we could prototype and understand how it is to kind of like do this. And we do this through, you know, education, entrepreneurship, and community building through the past like 5 years that we've been kind of like in New Zealand. And then, so one of the other things that we always get asked is that, you know, why even focus on space when there are so many problems like on Earth right now that we can potentially be focusing on. But, you know, besides the general like rockets and rocket ships that are very visual about the space industry, what we're really focused on is leveraging space technology to solve like grand challenges on Earth. And so, which is why, like, if you look at the United Nations Office of Outer Space Affairs, each one of those UN SDGs are actually represented in their website, and that space technologies are actually being leveraged to basically address those UN SDGs, from you know, looking at the health of planet Earth through like the weather, you know, disaster relief, like wildfires, and then there are other things as well, like methane sat, and we'll talk about methane in a little bit, just to understand how that 90% of actual climate change monitoring is now actually being done by satellites. So other applications as well that are also focused on Earth today, like in New Zealand, there's this company that called Starboard, and they can now also monitor like shipping lanes, which then can also monitor like illegal fishing, or also biosecurity as well. And then in terms of precision agriculture, now there's just the satellite applications are now, and the sensors are now very sophisticated, that they can count trees, they can count fruits, they can actually see mostly like the health of plants as well. So in general, what we always think about the space industry is really all of the segments of the space industry, and all of all parts of the supply chain, not just building rockets or building spacecraft. And I just wanted to point out as well that if you look at the global space economy today, which is over almost $500 billion, the kind of like the pie, the biggest part of the pie there is really on services. So this is what we call downstream, where remote sensing and data applications are really where the opportunities are. And at the same time, it's also that the opportunities are lower hanging fruit, because capital is not as intensive when you're focusing more on data and software.
And a big part of this, the motivation, and even for us, you know, when we were in California, we were seeing the opportunities that come from these exponential technologies, these technologies like computing that are advancing very fast, you know, doubling every couple of years. And so it not only is it, you know, driving powers of computers, but also suddenly you have all these AI applications appearing, you know, within months and things like that. So there's a tremendous power that's been advancing in the computing area that has been spread to lots of people around the world, and we just want to make sure that people are able to take advantage of this. And so another thing that has been happening is the sensors on the spacecraft have gotten a lot better at measuring the health of plants or small deviations, even in changes in the environment, and as we mentioned, the tracking of ships. And so these things that all these elements that used to cost, tens of thousands of dollars long ago, access to the satellite data or the analysis software or the computing platform, they've all been reduced in cost and increased in capability, so that,
And they've been open source.
yeah, and so like the software is now open source for many of these applications, and the access to the data is opened up, and your own computer is more powerful than what we used to, the specialized computers we used to use at NASA. And so this is why we our motivation for opening these challenges up and saying, and hoping to communicate to the people that and students that they have the power to address these global problems with their own computing power. And so we've tried, over the years in New Zealand, we've tried all these different efforts in activities to support this growing space ecosystem. And the challenge competitions is something that we've focused on as a good way to trigger lots of activity, bring in new people, and actually solve a problem you pose as a problem. And so there's a long history in aviation and space of prize challenges, even going back to Charles Lindbergh almost 100 years ago, with triggering the aviation industry. And so what when you set out a prize challenge, you get a dozen different approaches in potential solutions. So our last challenge we ran, we had 20 potential solutions to, in that case, it was how much carbon is being sequestered in trees and vegetation. And we had, it was building partnerships around the region. And actually the winner was from Fiji, and did a great job about being able to use satellite data to quantify how much carbon is being sequestered in trees. So some of these different solutions from our challenges in the past, we had people running around with lasers measuring trees in Australia, and connecting with lasers from space. We had people able to detect pollution using watching just the color changes in lakes. I had students monitoring the health of coral reefs with remote sensing data, and the down here is the one from Fiji, where they were actually using high resolution data and be able to measure for individual trees. And so on this challenge, we're once again focused on climate change, and you're quite familiar with the increasing heat that's going into the Earth system caused by the greenhouse gases, and that putting all this energy into the Earth environment is changing weather patterns, is drying out regions, is moving water onto other regions, increasing the chance of fires across Canada right now, things like that. And so all these caused by the emissions of these greenhouse gases, the most of the effect is and most of the problem is the carbon dioxide, but methane is an important piece of this. And the methane is actually identified by the IPCC and the scientists as saying, if you can, it's the most cost-effective near-term solution to reduce global warming. And just as we have different lecturers and record different experts talking about this, and I keep stealing charts from them to add to this presentation. But this is the spectrum, the visible light and near infrared, showing where methane is detected. And these near infrared ones are where the satellites usually measure the emissions of methane, but it's really over here in the farther infrared, in the thermal infrared, where the warming effect happens from methane blocking this light from being emitted from the earth and acting like a blanket to hold in the heat. And so so the methane is incredibly powerful, more powerful at blocking heat than carbon dioxide. And so, and there's different sources, like from agriculture. Each cow can emit like 100 kilograms of methane per year. Industry is the biggest source, and then you have other sources like landfills that emit methane. Of course, there's on the global scale, there's huge emissions from the big countries, but it's a problem that many of the countries are very concerned with. But if any tools that we find in our challenge, we can instantly apply to around the world. And so this is some of the big methane sources that are mapped using some of the freely available data. And you can see that there's industrial areas and pipelines are major sources. And if you zoom into our area, there's some, Australia has a number of emission sources from especially old mines that still emit methane, and there's less emissions in our area, but everything that we detect in this challenge, we can apply across the world. And so this is sort of the whole methane cycle, with the natural sources over here on the right in green, and then the human emission sources with the industry and agriculture and biomass burning over here contributing on the left. And quite a bit of this human emissions are being absorbed in the natural system, but there's still this 10 million tons. It continues to grow. And so methane has been crawling up, increasing in the density in the atmosphere. So we have in New Zealand, there's a concern about the agriculture emissions, and they have elaborate procedures where they put sheep in boxes and things like that, and measuring and quantifying the methane emissions from livestock and pastures. But it's the aim is for us to really observe these things directly from satellites would be the ideal. And so this is at a lower resolution from the satellites that show the concentrations of methane across New Zealand, and New Zealand in particular does not a bad job on carbon dioxide compared to other countries, but methane accounts for half of the greenhouse gas contributions. So there's a number of satellites current and planned for monitoring methane, and quite a few of them, the major ones, are freely available data, and that's what we're offering as a start for this challenge, is for people to use some of these data sets that are out there. And this is in some, we're preparing analysis capability for next year's, there's a satellite methane sat is going to be launched, and it's partly funded by the New Zealand government, and it sort of fits in between the broad global mapping and the very specialized point source mapping. And but they still need to target the satellite And so the scientists are asking us to help identify where they should target the satellite to monitor the methane emissions. And so these are details about the satellite, but it's basically, sectors of, 200 kilometers on a side and about 100 meters resolution. So you can see it's being built and getting ready for launch. So this is the problem statement for the challenge. We're using satellite data in combination with other data sources, help develop scientific methods to identify target areas of methane emissions on Earth. We're keeping it very broad so that we can get different approaches, different ideas for this, and basically we're asking for things that help advance the research in these areas, and we'll be leaving having our judging panel decide, who has got ideas that can move these things forward and advance the work on this.
Yeah, and this year as well, we're using one problem statement, because the last time we actually had a different problem statement for the two categories,
For high school.
for high school and then for university. But this time we're using the same, basically the same problem. So kind of like to wrap up the last section here is for me to basically talk about the mechanics of the challenge in itself. So in a nutshell, there are really there's 3 stages to the challenge. One is to basically get into the incubator, which is stage 1. Stage 2 is basically to down select to the finalist that will then compete in stage 3, which is not until the 15th of March 2024 for the grand prize, and that the proposals for getting into stage 1 is basically open today until the end of August. So as I mentioned, there are 2 categories. There's like high school and university, and the judges for both are different. So and of course, the level of expectation is also going to be different, even though the problem area is the same. And really the requirements is just like, yeah, you either are a high school student or a university student and whatever level, or a startup. And for simplicity's sake, when we talk about startup, it's just that you need to be no more than like 20 in your organization. And then also that you're a resident, or basically you live, doesn't necessarily, don't care about what kind of visa you have, but as long as you're a resident or living in New Zealand, Australia, the Pacific Islands, including the Philippines, during this time frame of the challenge. So as I mentioned, the stage 1 is for the virtual incubator, and we're selecting essentially about like 20 teams from both of the levels. It's gonna run, and it's basically virtual, so it's all online, between October to February of 2024, where there is also a break in between for the holidays in December. What's in the virtual incubator? There's webinar sessions that will talk about or with specialists that will talk about the problem area, to those that are already working in the area for current solutions, some basically tools and skills for remote sensing. We're also in the process of getting potentially an aggregated like platform for the satellite data that could be utilized. And then of course, we're gonna look at mentors for those teams, depending on where they are and what they need. And the reason why we do this incubator is basically we want to help the teams really work on what they're going to be submitting as their final application. So really the first part is you're just really giving a proposal. And so the requirements for this is just 2. So basically one is like, who are your team members? So, the CVs or resumes of your team members. And then the other one is like a proposal. So the proposal would then include just the idea or the general idea of what you want to do, what problem specific that you're addressing, what's your plan and schedule, and then also what support you're basically needing. And so this proposal is due at the end of the 31st of August. And yeah, you can just go to the SpaceBase website where there's a button to kind of like click on the form. And then on the stage 2, which is then going to be, the deadline is February 25. This is where everybody then would submit like a full application. And what we're doing is that we're expecting that the teams from the incubator to submit applications, but also there's a workaround where if you did not get into the incubator and you still want to submit an application, that's also okay. And so the requirements are just, again, 2 things. One is like, it's just a 5-minute video demonstrating your solution. So it's a proof of concept. And then the second one is a presentation deck, basically describing what you've actually done. And so what we're doing is that we're down selecting to 3 finalists for the high school level and 3 finalists for the university and startup level. And so those ones, if you actually get into the finals if you get into the finals and you're a finalist, there's already, you're already guaranteed that there's some kind of cash prize that you're actually going to receive. And so the final stage is that pitch and demo session during the 15th of March, where then you compete for the grand prize, which is like 25,000 New Zealand dollars for the university and startup, and 8,000 for the high school. And then the finalists will get some cash prizes as well. So in terms of the judging, so basically the criteria is the same for all of the stages. And just so this is just simplified here, where there's really basically six elements. So one is, are you using space technology? Which is a given. But you can also use a combination of like space technology and maybe ground data as well. Second is like, is your idea like feasible? Is it scientifically based as well? So then the other is like, is it a new idea? Is it it hasn't been kind of like done before. Ease of implementation is one, like how easy is it for you to actually implement this? What's the environmental impact? Is it small or large? And then there's also, for the prototype, that's for stage 2 and stage 3, when you're actually showing either in video form your demo. And then the last 3 here is basically extra points. So you get extra points if there's evidence that what you're trying to do is implementable and the impact you can see in 3 years. The other thing is like, if you're collaborating with other stakeholders or you're collaborating with other organizations, that's actually a plus. There's also the creative integration, meaning that if you're not just using space, but you're also integrating other industries or other like scientific disciplines into your idea. And then the third one is team composition. So does your team have got what it takes to actually get it to the finish line? So actually those are everything that's on the mechanics, and I just wanted to point out and thank our sponsors and our partners, of which of course the government of New Caledonia through Mr. Mulyava is a big supporter, and so we thank you for promoting the challenge. There's also Decal Technopole, of course, who is hosting this particular briefing, and yeah, so we have partners and sponsors from all across New Zealand and Australia and the Pacific Islands, and we're still looking for funding as well, because we haven't finished our fundraising for the operations of the challenge. This is where you can basically email us yeah, we're looking for applicants. We're looking also for if you're an expert and would potentially either will be able to even like mentor like maybe the high school level is also an option. And then, yeah, we're also looking for sponsors. So I think that's it. Yeah, and again, this is the link to the platform, or just go to SpaceBase.co and then you'll find the button to actually apply. So I think I will
just stop.
stop and we can do questions. Thank you so much. Merci.
Thank you, Eric and Emeline. I think the students from LIFU, they have joined us, huh? Are you there? Vous êtes là ou pas?
Demetri, vous êtes là?
Ouais, c'est bon, on est bien là. Hello, everybody. Sorry for being late today. I had a little problem with the download of Zoom. So sorry again. Thank you for the presentation. So it's clear for us. I don't have a question. My student, they don't have a question, but we will see again the presentation and maybe we'll come back to you by mail. I don't know. We'll write.
And we recorded it, so we are certainly going to put it on the YouTube channel and we'll let you know when it's available.
Okay, perfect. Thank you.
Maybe just explain what Juvenile Desil is for Emeline and Eric, please.
Okay, so Eric and Emeline, Juvenile Desil is a kind of it's a group of students. This is the best student here in the Lycée des Îles, in the high school here in LIFU. They are doing some NSE, they know how to compute, they know how to they know a little bit about data science. So this is a good thing, and it's this challenge would be a good way to practice. So Juvenile Desil is
thank you.
Maybe to change the world.
That's a challenge.
So I don't know if you understand. Juvenile Desil is a program built by one of our elder who was he's still a teacher, but he's in retreat now. He's a professor of mathematics. So he tried to think how to help the student of New Caledonia to more be interested in science via mathematics. Yeah, so he built this program more than 20 years ago, and some of the professors from France come and help this program, and these students from the island are part of this program. So I think they are the best of the best of the high school of the province of the island province, who are dedicated to the science.
Oh, that's amazing. That's great.
And maybe I forgot to introduce myself maybe to these people, because I don't know if they know me, but I'm a member of the government of New Caledonia, in charge of innovation and technology. From 2019, we work with the head of the digital department, George Wapai, and another member of the government, Christophe Giges, who is in charge of digital economy. We try to work and to make the ecosystem of digital and innovation create an environment of development. And one of the first steps of this strategy was to build this place called Station N. This is where all the startup or the students through the article for innovation. They have their own program with the students, with the university, but also students from high school. The program like Startup Article and Pepitense, they work with the university. And I just wanted to support you because not because I like you, but because your ambition is good for us and for the world. I support the one of the three key of your space challenge, the democratization, and I think our kids have to step up into technology, because I believe technology and digital is the new ocean, and we have to master this new ocean, technology, digital, all that kind, even geospatial data, because as you mentioned, geospatial data open a wide range of solution. Not only geospatial data is not dealing only with the fusée, comment on dit ça, fusée? But they gave the human being the opportunity to shape a better world with all this data through the geospatial. And the second key of your space challenge is you give the opportunity for the student and also for the startup to fill a lack in New Caledonia of specialized incubator. We have a general incubator here, the pole innovation of the Adical, but we need a specialized incubator. And your challenge is not like the ocean hackathon, 2 days, then good morning, goodbye, and but you have a challenge in the long time, with the selection and incubator training. And the third key is you speak English, and we live in New Caledonia, and New Caledonia is in a space where everybody speaks English. So we have also to step up into the English speaking, but not only speaking, but English way of thinking things. Just to add to our French way of approaching things, but we have also to work on that, and that's why I would like to thank the International James Cook School to be part of this, because they work with our kids on this part of construction of their identity. This is really important. James Cook is here from how many years now?
15
years.
Yeah, nearly 16.
Yeah. And I know some kids who went at this school, who went after that at the university in Australia or in New Zealand. So this is really important for us, for me, that James Cook is part of this, and the children, the program of Children des Îles. And the other things I support this your challenge is because here we have, of course, we have a startup here, specialized in geospatial data. We have Bluesham here, and they now can comment on dit ça? They can challenge with the international game, and this is one of our pepit here in New Caledonia. They open the company in Australia they work for Europe. So this is really important also that our kids know that we have also our own local hero here.
Yeah.
And we have another one inside. He's still a baby, I think, because Bluesham is already spread all over the world. But I would like also that to see other new actors in this field.
Yeah.
Because geospatial data, like you mentioned, it can cover a wide range of thematics.
Yeah.
So this is really important. That is why I would like to thank also Laurent Bui, who worked for the pole innovation of ADECAL, because this is really important. I'm really sorry there are not many of us here, but you know, this is really difficult. I support also last year the SPC, South Pacific Community, with Database Challenge. This was the first edition in New Caledonia. We had 3-4 candidates. 2 of them were granted for their proposal. So this is only a start. This is only a start, and I know that the journey. This is a long journey. This is a long journey, but at least we have to start something. And I believe James Cook is here, Juvena is here, Bluesham is here, the API is here. So we don't have the quantity, but we have the core, the quality.
Yeah. We're so lucky to have met you, and you were such a great champion of this activity. And I can see your vision is much broader than, and we're just one element.
Yeah.
And we're happy to contribute.
Maybe there's any question.
No, for the moment, that's all right. I think that we need some time, in fact, just to organize and to think about the challenge, because that's a very interesting challenge for our kids, I think so. And we'll try to do our best, in fact, to
With the deadline.
with the deadlines, actually. Yeah, that's really interesting, and thank you so much for inviting us. And and we'll do our best, in fact, to help you, because I think I agree with you, because I think that's a very interesting challenge for humankind, and that's as for me, it talks to me because it's for humankind. Yeah.
Yes, at least 2 questions, maybe more. I think the first one is based on previous challenges. What's happened to the winners? I mean, both for students and for startups. Do you have some success stories to share with us in order to, I think, put some ideas to the audience here in New Caledonia, and or they can spread their solution into the market? And the other question I have is about the management of intellectual property of the proposition we are making in this challenge, basically. Thank you.
So I'll answer the second one quickly, because you own your IP. So there's no
Each team.
Yeah, each team owns whatever it is that they actually come up with. And so that's one question. And then there's the first one, basically, so there are different, I guess I can talk about different like examples. So for example, one the winner last year, which we were talking about, was from Fiji. They're actually a consortium of like 14 PhD students that are from different universities across the Pacific, although they're mainly from Suva. And so now what they were focused on was basically carbon sequestration and how you measure carbon sequestration so that it could be potentially be leveraged for carbon credits. And so
they're both on the government side and on the private side.
Yeah.
And
so today, again, this was just basically, this was last year, so they're still in their process of developing and making their methodologies better, but they're collaborating with the Fiji government on potential implementation of their research. So that I think that's one thing that we were really happy about, that came about, where the connection between them and the Fijian government is still ongoing, and they're also like leveraging still some of the satellite data that they had, because we had a collaboration with satellite company Planet for carbon sequestration.
And for the winners, we give mentorship, to for another 6 months to help them identify how to apply their winning solution. And one advice we're giving, the Fiji group is that their system actually has a direct application to New Zealand in 2 years. There's going to require all the farms to quantify their carbon sequestered, so that there's a potential market in New Zealand, for example.
Yeah.
So
In terms of like high school is a little different, because depending on where they are in their grade. So for example, the winning team were all seniors from Wellington last year, and the main principal person of the team is now has gone and applied to University of Auckland, and he's now doing his bachelor's, while the other teams that are like a little younger, but they got to the finals, they're now doing from what I understand is they're creating another team to apply for this particular challenge, and they're part of a space club within that particular high school
but even the high school teams were addressing international conferences on their results.
Oh yeah, right.
And so that was
Yeah.
and so they were able to use that in their applications for what their further career and things like that.
Yeah.
So
in the past, not the Space for Planet Earth challenge, but we kind of like delivered another one, the Aerospace Challenge, for the Ministry of Business and Innovation here in New Zealand. That one was just like a national competition, so it wasn't like regional, but just like 2 examples there is that one of the finalists as well, having gone through the incubator process, and he was at least he was giving us sort of updates on how he was implementing it in his own startup, and then one of the mentors that actually helped them then became basically an investor and a board member, and then they also had the solution that they were working on was also leveraged by local government for one application. So I mean, that's kind of like one example. The winner from that year, they're this company called Sequent. They basically created, the reason why they did the challenge was they created another business line where they didn't used to be leveraging satellite data, and so therefore added that business line for
so they commercialized the product. Yeah.
So I don't know exactly where it is now in terms of the product that they created, but that's like just one example.
We also had another question. We were wondering, for the high schools, is there like a size for the teams? like a minimum size, the amount of team members or maximum amount of team members?
Yeah, that's a good question. I've been asked that several times. Actually, so we don't have like a strict rule, but just from experience, we've had teams from 3 to 6, like individuals in a team. But then again,
seem to be a good mix.
Yeah,
We
that's-
have had larger ones, but you know, a number of people sort of drop out.
Yeah, so I think if you have a kind of like the right size enough where the team members are engaged, I think it's a better staying power for the members of the team to be part of the
And a big part of this is, of course, you know, there's no application fee, and if you get into the incubator, it's like a
it's
online.
actually a price already.
It's online training system, so it's a.
And for some people, I think they think that it's probably even better than the cash prize, because that's really where you hone your skills, and then also get into the network. You also interact with other teams as well while you're going through it. So yeah.
Maybe I have other questions. You encourage partnership and collaboration. Ecosystem here in New Caledonia is quite small. Or what about, for example, if my company is applying for the challenge in the startup section, and we develop a collaboration with James Cook High School, or is it possible, or you completely forbid it?
That's actually an interesting question, because I think your scenario, you were saying that the James Cook is applying in the high school level, and then you're part of the startup level. Yeah, I think that's a little bit complicated, because it's very hard for the judges to.
You have to have someone that's sort of in the lead and saying whether or not it's a high school application with your support, or if you're supporting and inviting the high school to participate. And so, yeah, it's just a matter of the judges knowing where to evaluate you in. So or you can just do it both, 2 applications.
Yeah. So it's a little complicated about being able to, because like depending on what you're working on, it has to be 2 separate like ideas, to be like 2 separate.
I was thinking basically about 2 separate ideas, and maybe if James, it can be the same for other companies, basically. In the general statement, if James Cook is searching for some collaboration to help their students evolving in the space industry and space science, maybe they will search for existing expertise. So we possibly be contacted by them and applying on our side on separate.
That works.
That would be good.
Yeah. That definitely works. Yeah, it's only when I was like thinking that if it's the same, the same problem area, the same solution that's being split is a hard one. But if you're just basically your role, for example, the James Cook is putting in as an application, and your role is more like a mentor to them or advising to them, then that's certainly that's fine. And then for you, if you're applying for your own, they're really just like collaborating as a different entity that is another organization.
To continue in this question, if like Bluesham wants to work with collaboration with other industry or other partner, but in Australia or France, is it possible?
Yes, that's also good because again, just like the winning team last year, as I mentioned, I mean they're kind of like their base is in Fiji, but they also have universities like there was one applicant, there was one team member that's in Australia, there's one team member in Spain. Yeah, so yeah, it works.
Yeah, it's mainly who's the lead on
Yeah.
the team that is the determining factor.
If you said that one of the key criteria about the first submission was innovation, how do you quantify the degree of innovation as is an existing mix of solution? A mix of existing solution could be an innovative way of response to the problem statement, or
Yeah, it's we are basically letting our judging panel argue about these things, but you can certainly build on, you know, approaches that have been worked on and
then you're adding and
you know, or it could be, you know, like because there's only a certain number of satellites that have the ability to detect methane right now. If you can start with those and or you know or combine them in a way that is you know, it basically goes back to the judges and say, you know, are they advancing the approach in this area? Have they come up with a new mix of using this data, or you know, or a different way of looking at it? Is there and so it's yeah, we basically are leaving this problem statement very broad in order to try to encourage different proposals, and we'll see what comes out. It's I don't, I'm sorry, that's not a very specific answer, but it's
yeah, it's I guess from experience, it really will depend on how the judge. I mean, it is quite a. I mean, I don't know if I can say like subjective way of judging with depending on like a group of judges where how they kind of like interpret how innovation is for the different, like they're basically ranking just the innovation ideas that are going to be put forward by all of the applications. So there's like, yeah, there's no cookie cutter way of like saying, you know, that these are the kind of like the specific points for the innovation. I don't know if I've answered your question.
Yeah, thank you. And about the technology readiness level, you said that there will be a proof of concept 5-minute video to demonstrate in the second application. So I think I suppose that there is no technology readiness level needed to apply.
Not a specific level. It's sort of to show that, you know, some progress over the period of time between the
time that you put the proposal in and the actual application. So basically, the proposal deadline is the end of August, and then in an ideal scenario, you go through the incubator program, and then by the time that you actually submit your final application, that there is some progress that can be seen between what you're proposing and what you've actually created at the end. Does that make sense?
Okay, thank you. Yes, that makes sense.
I have another question. Is there already a potential customer of the solution of the challenge? I mean that do you already target, for example, methane sat team as a potential customer at the end of the challenge to continue the work, develop the service, and then put into the industry?
Yeah, that's a good question. I mean, it's not officially saying that that they are the customer, but for sure, because we are one of our sponsors is the University of Auckland, Auckland Space Institute, which is actually where methane sat will be operated from. So they are very, very much interested in what comes out of this. And while there is no officially saying that it will be implemented, but it's certainly like the most important reason, kind of like why we're doing this, because methane sat is coming shortly, and that the data that will be available when methane sat comes on board will certainly be that's the goal, is to be able to leverage that data using the solutions that they come up with.
Yeah, and we're also reaching out to, there's various UN organizations that are managing the methane data. There's industry groups. There's actually a large global investment in this problem, and so anything I think that the teams, if they come up with useful intellectual property, will find the whole world is interested in this issue and is actually investing large amounts of money to address the methane problem. So.
Yeah, especially that methane right now, as we mentioned, there's not a lot of satellites that are actually focused on it right now. It's a new, it's definitely a problem, but it's something that has not been focused on as much as like carbon is.
Yeah, but the challenge is really focused on a specific area of methane. I mean, identifying small leaks, which is basically excluding oil and gas industry that can provide money for service. So
no,
we are.
No, so which is why we kind of like did the problem areas as a really broad SWOT. We're not saying basically we're just like saying methane emissions on Earth. So it could be either from industrial leaks, it could be land fills, it could be in New Zealand, for example. The most important thing for them is really agriculture. So because we don't really have a lot of like industry factories here, but and so yeah, any of those are potential problem areas to focus on.
And it might be interesting, that there's not real strong emissions from the Pacific Islands, but it might be interesting that some of these low resolution data sets, you can say that anything that comes from this area is coming from the island, and so that may be useful for quantifying emissions and looking at the time history of these things. And so it's basically there are some we are making available on our website some information about existing levels of research, and but we're trying to encourage people to take that and go beyond and get ready for when the methane sat data is available, but also just contribute around the world to this issue, because it actually it looks like if we can control the methane, it will buy us time for all the other greenhouse gas reductions.
Thank you.
I have a question. We're currently thinking about the students that we could offer this challenge to. Our students would be probably currently in year 11, and in year 12 they do a project that's called research project. And in the research project they have to pick a key question on which they're going to work, and they're going to develop their whole project on that. So they would begin in February and they would finish in July. Obviously, if some of them have started working this year on the topic, could they pick something that's a bit similar? I mean, would it be okay for them to work or to use some of the data that's been used? I'm not quite familiar with that, but I was wondering if it would be an issue that if they were using the data both for the competition, the challenge, and also for a school project, which would then lead to their graduation.
Yeah, sure, that would be fine. And and it would be, I think it would be very valuable if they could think about the idea before the end of August and get into the incubator. I think they would be really benefit from that.
Thank you.
Maybe a last one. A short one. Do you know if the MethaneSat data, when the satellite will be in orbit, the data will be free because that's a uni satellite, or does the data will be in the commercial market?
I don't know exactly their policy, but I think it's the two sponsors for MethaneSat are the New Zealand government contributing, a fraction of it, and the Environmental Defense Fund. It's a
nonprofit,
non-governmental organization in the US, and I think their objective is to share the
actually
data.
share the data.
Yeah.
So that's at least that's kind of like what we.
But even if it launches in the early part of next year, it's going to take a while to check out, and it'll take a while before the data is being released. But it is aiming at being sensitive enough to detect very low emissions. We're trying to establish, we're talking to some of these other commercial companies, but so far, of course, they're very reluctant to share commercial data.
Any other last questions?
Other questions?
And one point about this is that the same, as you're aware of, the same analysis procedures that you develop in this approaching this challenge really apply for so many different areas, from land use and ocean health and all these other all sorts of different applications. And so that a big part of the challenge is the capacity building, to train teams
and transportable skills that can be used for other problems. Great.
Great. Either one.
No more questions. I just want to thank our local radio station, RRB, Radio Rythme Bleu. She's still here. She's still answering to the call of the government. So I just want to thank her. Because she will relay what we are doing now. So thank you. Thank you to James Cook, Bluesham, Happy, and to the Jevena Desil, and to you, Eric and Emmeline. Of course, I like you. Of course. So this is only the starting. I guess Laurent will answer all the questions for the applicant of New Caledonia, and he will be the bridge with you if, of course, if it's necessary. I think he will keep on working in the University of New Caledonia to be part of this challenge and also other startup of New Caledonia. But I believe we have the good messenger, the right messenger for this space challenge. And as the head of the James Cook School said, this is for the well-being of humanity. And you mentioned something really relevant for me. It's not only about detecting the methane or carbon or the trade code, ocean sea level. It is also economy, land use, and we are an island. We have small resources, very few resources, few land, few water sources. So this is really important and crucial for of course for the humanity, but for New Caledonia too. So it is really important. And once again, I would like to thank James Cook School, Bluesham and API and Juvenile Desil, because we still focus on Europe and we live in Oceania. And Oceania is built with the two big canoes, Australia and New Zealand. So through this space-based challenge, I believe that in New Caledonia we have to work our be identity, be cultural, and we have to speak English. So this is really important. The tremendous work James Cook has done so far from 15 years now, because this is our future. Our future is of course linked to Europe and France. This is not something I'm questioning. I'm only questioning our capacity to work with our neighbors. And Australia and New Zealand have a strong history with New Caledonia. I work in Townsville at the Museum of Tropical Queensland in 2005, and I discovered that this town was built by Robert Towns, and Robert Towns was a really good friend of James Paddon, and James Paddon is the father of the city of Paddonville here. Was called Paddonville in the old time, but now it's Paita. So and James Paddon come from New Zealand, So we have a strong link. Of course, we have our oceanity, 3,500 years, but through the 3,300 years before us, we used to work together. So it is really important. And as I mentioned earlier, technology is the new ocean. It's the new ocean. So our kids, we have to enhance our kids and support them, to give them the tools for being the captain of this new ocean, the technology, the digital. So this is really important. And working with New Zealand is not an option, like working with Australia and all the islands of the Pacific is not an option. It's a duty. It's a duty. So thank you.
Yeah, good.
Again, thank you so much for the opportunity and the time. I know you're all busy as well, and this is probably like holiday time as well for most universities and kids. So we do appreciate the time that you've given us. And yeah, if you have any questions, please feel free to just contact us or Laurent, and we'll definitely be expecting your proposals as part of the teams that will come from New Caledonia.
Thank you so much.
Thank you. Bye.
Thank you so much. Bye.